Hello. I'm very happy to be here in the land of my father's grandfather, paternal grandfather, actually from the Franche-Comté. That's my name, but my French. I wrote this abstract, and actually the reviewer for this abstract said, well, what is important about a snapshot? And I thought, well, that's a good question. And I think for me, it's just before kind of plate tectonics and oceanography is becoming part of the story leading to plate tectonics. But in fact, in preparing this talk, I decided to focus on a specific topic, and we'll get to that, the origin of submarine canyons. Well, how did I find out about this meeting in 1958? In fact, I learned about it because I was writing a paper about Robert Dietz, who was both a marine geologist and an impact geologist. And he gave a talk at this meeting about the origin of the Pacific Ocean by meteorite impact or asteroid impact. And I brought some reprints. If you're interested in that paper, I'm not going to talk about it. Well, at the time, in the middle 50s, Dietz was working for the Navy, the Office of Naval Research, as what we call a scientific liaison. That means he was an overt spy. He was attending meetings and writing reports back to the United States about the state of science in Europe. And these are 4 of the reports that he wrote about marine geology, in particular in France. They rest in the Scripps Institution of Oceanography archives, but there are also copies, for example, at my university, because the reports were distributed widely, maybe to about 300 people in the United States, both the Navy and government, but also to universities. So I decided to focus on the origin of submarine canyons, thinking, okay, that's a focus, but it's also a huge topic. And so I've learned this is a work in progress. I wanted to look a little bit about the means of exploration developing in the 1950s, and also the influence on ideas about the origin of submarine canyons. This is an early aqualung exploration of the canyons and also a drawing of the submarine canyons. I'll say a little bit more about these because maybe some people here don't know that much about submarine canyons. So these are canyon-like features. They commonly start as valleys, as they do. Oh, where's the pointer? The pointer is, sorry. I think I can use this as a pointer. Okay, thank you. Well, this is one of the earliest maps of actually a submarine valley originating from the Hudson River at New York City across the continental shelf, and there we call it a valley, and then a deep cut into the continental slope. Both of these maps were actually based on work done by the U.S. Coast Survey in the mid-19th century. I cite Dana because he's the first one commonly credited with discussing an origin for these, because other people had noticed them, including Darwin, and others had written a little bit about these submarine valleys because soundings were finding you would go across a shallow area and then your soundings would go much deeper. But Dana suggested it was a valley that had been eroded by a river and then drowned by later sea level rise. And he really only talked about the submarine valley itself. By the late 19th century, a number of these submarine canyons by various names, trenches, canyons, valleys, Rèche in France, had been described and mapped in some still relatively crude detail. In addition, on the west coast of North America, the canyons of California, which become important in the story. Others that had been mapped by the early 20th century include the Congo, Submarine canyon, which is unusual in that it goes all the way up into the valley, so it's clearly associated with the river. And then the Gulf or Fosse de Capbreton, which actually doesn't have a major river associated with it, the submarine valley in the Bay of Biscay. Mediterranean bathymetry had been mapped by the early 20th century. You can, if you see little dots on here, those little dots are actual soundings. So it's not a lot of information. And in fact, you cannot really see submarine canyons on this map, but this will become part of our story here. So we say in English, I went into a rabbit hole. And this is Alice in Wonderland when she fell down this hole and it became very complicated world. So in looking at the origin of submarine canyons, it clearly became a very large topic, which is probably a book worth of information. So this is maybe probably not a complete list, but a list from 1863 to 1959 or this 58 conference about ideas about the origin of submarine canyons. And you can see the dominant color is for subaerial erosion by fluvial processes. And the blue colors relate to cases where people think the origins were definitely underwater or could have been underwater. And then there's some other ideas as well. So it's definitely dominantly interpretation of subaerial erosion by fluvial processes. Now I should say, if I went back to the map, if you're not familiar, these canyons go down to depths of at least 1,000 to 2,000 meters. So if you change sea level by building glaciers, you only get 100 to 200 meters of change. And so you have to suggest something else dramatic, either much bigger glaciers or some tectonic control in order to explain the subaerial erosion. Interestingly, and I'm not sure why, maybe increases in bathymetry in the 1930s, a lot of different ideas were published. Some of them had earlier representations, but ideas about their fault bounded, that of course they're built up on either side, like reefs could build up and leave a canyon in between, and even tsunami erosion, which is something I have interest in otherwise. But and for those of you who want to know the answer, which as a historian, I mean, I am also a geologist, but I don't really want to know the answer. I want to know kind of why, or how people thought about things. But I said a 2022 preprint I found said like the evolution of submarine canyons remain topics of ongoing debate and require further understanding. And my exploration then is, or my sort of what I can summarize now is that subaerial erosion hypotheses appear only to have been slowly abandoned and were still active in the 1950s. I only went to the 1950s. The first proposals of subaqueous erosion were in the 1930s, and that's some version of subaqueous erosion is the modern hypothesis. But my question is, how and why did people's minds change? So the cast of characters involved, in particular, were mostly involved in the meeting in 1958 or meeting just preceding that. In particular, Francis Shepard is probably, for those of you who know submarine geology, he would be a major figure and published on submarine canyons from the 1930s until the early 1980s, but I'm only considering up to 1958. A major figure too is Reginald Aldrich Daly, who is the first one to propose a subaqueous erosion hypothesis by density currents. And basically Daly in his paper in 1936 said no published explanation of these canyons by subaerial river cutting seems adequate or permissible. So he proposes a new working hypothesis. And this is the hypothesis that during lower sea level, there was a lot of agitation of the sediments on the edge of the continental shelf, generating what we call density currents, which had first been described by François Alphonse Forel in Lac Le Mans, and that these would be driven down the continental slope and generate erosion. So amongst others there've been other work, mostly in reservoirs, documenting these sediment-laden density currents flowing from river mouths into lakes or reservoirs, but not so much into the oceans. Well, Daly said a definite answer cannot now be given, but the general hypothesis should be tested by appropriate observations. Well, he didn't have long to wait. Philip Kuenen in 1937 conducted experiments, and in 1938, in particular, examined this question: could density currents generate enough erosion to generate submarine canyons? And his answer was basically yes. Well, virtually all these people, and then some more characters we'll talk a little bit about, were involved in the 1958 meeting or a preceding meeting. And so we'll talk about these different people. Daly had died by that time, but he was actually a professor of Francis Shepherd. And Francis Shepherd was not at the 58 meeting. I'll talk about the preceding meeting, but he was the PhD advisor of both Dietz and Emery, who were at the meeting. And we have Kuenen was there, as well as we'll talk about Jacques Bourcart and Louis Glangeau. If anybody knows a picture of Louis Glangeau, I could only find one of his father. And Bruce Hazen was there as well. We'll mention him a little bit later. So there was a previous meeting with almost the same title. It was held at the Sorbonne in the Laboratoire de Géologie Sous-Marine that was started by Jacques Bourcart. I didn't mention the 1958 meeting was held at Villefranche-sur-Mer, at also a laboratory near Nice on the Mediterranean Sea. So Shepherd, Kuenen, Bourcart, and Glangeau were there. Dietz was there as the reporter, or the Navy, telling about this meeting, and that's the information I have. There's, as far as I know, not a publication from this meeting, but Dietz said in his 1955 report that Shepherd presented a concept of canyon origin, but with a major emphasis on subaerial river cutting during a period of marginal or peripheral uplift of continental blocks. Now, Shepherd had earlier proposed a mega ice age glacier that had lowered sea level 1,000 meters, but he had abandoned in 1930s, but he had abandoned that by the 1950s, but he had not abandoned the subaerial erosion hypothesis. At the same meeting, there were talks, in particular, I'll just talk about Jacques Bourcart and Louis Glangeau, and they're talking about the French Mediterranean. And there was a recent bathymetric chart of the Mediterranean. Actually was, I think the public version of it was published in 1960, but there are earlier versions of that even at the meetings. So Bourcart had a concept of continental margin flexure. That is that the Mediterranean would go up and the Alps would go down, for example, back and forth. And that was his means for bringing up the land and generating this period of subaerial, the subaerial origin of submarine canyons. Glangeau discussed the same topic, essentially looking at submarine canyons off the South Mediterranean, the coast of Algiers. So in 58, these are the people who were at the meeting in Villefranche-sur-Mer, just outside of Nice. And I think I've already introduced them all briefly. So, Bourcart and the report is entirely in French with short English abstracts. I don't know if all the talks were given in French, but the publication is in French and the discussion is all translated into French. Bourcart and Glangeau's talks are essentially similar to what Dietz summarized from the 1955 meeting. They proposed that these areas had been uplifted at times and that there was subaerial erosion that generated these submarine canyons. Interestingly, this meeting, Kuenen didn't talk about turbidity currents or submarine canyons. He talked about the Ertaud sandstone, it's Oligocene in age, and proposed that because the source was to the south, that a part of the Mediterranean had to have been above land and mountainous in the Oligocene, and that it had since subsided 3,000 meters. So in a way, he was supporting these sort of tectonic hypotheses. Menard was there from Scripps. He at least argued that the abyssal plain, oops, sorry, up here, the abyssal plain is a result of turbidity current deposits that are smoothing out the ocean floor. And Emery, who was Shepard's student, talked about the California continental borderland, which in the California view, the borderland is much more vertical tectonics than the flexure model of Bourgeois and others. What are you doing with time? I'm almost out of time. I think I'm going to jump. How much time do I have? 10 minutes. Okay. There was, of course, a discussion about bathymetry and also, of course, always nomenclature at these meetings. And I think I'll jump over this, but interestingly, the French proposed a definition for submarine canyons that had a lot more genetic connotation than was in the proposed international or English definition. Of course, at this meeting, there were people like Jacques-Yves Cousteau, had just become the director at the Institute in Monaco, and people were starting to use the bathyscaphs or the submarine exploration, and of course, a discussion about the new use since World War II of the aqualungs for exploration of these regions. So I'm going to jump over this, but it's basically looking at the increase in technology and information and the kinds of information that was coming forward in the second half of middle of the 20th century, including exploration by submersible, a French submersible of submarine canyon off Lisbon, and that is, it's painted, newly painted, I'm sure, but that is the CNRS 3 that made one of these dives in a submarine canyon. So what influenced the views? It's clear to me that bathymetry did, and as well as the age and composition of canyon walls. Some of them were granite, they were steeped overhanging. The people associated that with fluvial erosion. They didn't imagine it for turbidity current erosion. And then there are how do you explain the sea level change if you have a subaerial interpretation? And there are many fairly, the explanations become more and more complex. We tend to see that in a science when there's going to be an overturn in ideas, that people just have to keep coming up with more complex explanations. So just briefly about bathymetry, the bathymetry was being improved, but it's clear, for example, with Shepard in his subaerial interpretation, he draws the tributaries of the Monterey Canyon, which we heard a talk at Asilomar about the Monterey Canyon, if anybody remembers that. He draws all these little tributaries, which frankly, I don't see on the bathymetric map. So it's clear that people are seeing things, in the data that will match their idea of what's happening. Bourgeois says the same thing in his review of submarine canyons in 1950. They present a fluvial morphology with meandering, zigzagging, and with many tributaries, even though I can't really see them so much in the data that existed at that time. So when you jump to a new set of bathymetric maps came out in the late 1930s from the U.S. Coast and Geodetic Survey, and this is just a comparison of what a terrestrial topographic map would look like if you only had bathymetric data. So it's clear people still don't have a whole lot of data. So Veach and Smith generated a lot more data, and they produced this bathymetric map, which looks really weird to me, frankly. And in fact, there was a critique of this bathymetric map. I mean, what you have to do is connect the dots. Here are the actual data, and here's some more data, and then you're generating information in between. This is how contouring is done. And so your ideas can influence, how your contouring is. And this was in a review of this contouring, it said the authors have assumed the bottom forms are similar to those due to stream erosion on land and drawn contours like that. And Veach and Smith acknowledged that. They said that's the best they could do. But yet, like, if you looked at it, it looked really weird. It didn't look like any topography that or bathymetry that you might have seen. And in fact, Shepard, in a later publication in 1966, redrew, using the same data, redrew the bathymetry. And so even Shepard, who supported subaerial erosion, said, like, well, this doesn't look like, what we see. So I'll jump over that. That's a critique of the this bathymetric contouring. It's not drawn, it's drawn by a hydrographer who doesn't know geology, or they don't know what they're doing, or they're assuming drainage control. So bathymetry just brings me to this little, this other topic. At this meeting, Hazen presented the map of the North Atlantic, first published in 1957 by the Atlantic Cable Company. This is the earliest version of the map unfolded, done by Bruce Hazen and Marie Tharp. And so at the same meeting in 58, he proposed that this submarine geology supported continental drift. And for me, this is like also a cusp. It's something changed around this time and may have influenced Dietz, who a few years later wrote about seafloor spreading. Interestingly, when asked about his bathymetry, like, could you give us the data? And Hazen had to say that unfortunately, this material was classified. After the war, the U.S. started fairly strictly classifying these bathymetric data, and that's a topic of a recent book by Naomi Oreskes in Science on a Mission, the influence of sort of the military on scientific research at the time. So the increase in information actually tended to favor the subaerial erosion hypothesis because they found these granite walls and overhanging canyons, and people took the bathymetry, improved bathymetry, and it didn't seem to change their minds. And so these hypotheses dominated through at least the 1950s and seem only to have been slowly abandoned. And I think this is like when we look at, quote, scientific revolutions, of which this might be a small example, that's like what actually changes it. Just well, Shepard didn't die, and I don't know how his ideas changed isn't topic of a whole book itself. And so I don't have an answer for how these changed. I just want to end with an homage to Jacques Bourcart. I knew nothing about him before this meeting, and he had wrote a lot about the submarine canyons of the Mediterranean, including the Reche Le Cas du Thiers. And there's an unnamed canyon right here. And guess what happened? I don't know exactly when this happened, but this was named, it's now named Bourcart Canyon. And this is a 21st century idea of how much more we know about submarine canyons than these people did in 1950. So how those ideas, it's just only a work in progress, how those ideas might have changed. Thank you.
Thank you for this very interesting talk. Are there some questions?
Thank you very much for your wonderful talk. I have seen some of this data, but always in connection with the deposition of turbidity currents at the bottom of the sea. And Philip Kühnen was actually, I think, the first one who really proved that those turbidity currents existed. He had a flume in his own garden.
Exactly. Right.
And published this with Migliorini. If you look only at the erosional features and you see the meanders, then you must also look at the deposits, because the meanders are specifically in the turbidite fens that are usually at the lower end of those canyons. So I think the idea that it was really the turbidity currents who did it is principally indeed from 1938 onwards to the late 50s, thanks to Philip Kühnen.
Right. And if you remember this talk about the Monterey Canyon at Asilomar, our meeting in Asilomar, they showed people thought only at low sea level, these are happening now. And they showed these big blocks that had been moved. They have, now they have all these little cameras in there and they showed like really big blocks that are being moved. And so I think people, and then up till the 1950s or even later, they could not imagine, probably maybe even Kunin couldn't imagine the kinds of things that are going on today, active submarine canyons.
Thank you.
Yeah,
Thank you for an interesting talk. You had a list of different ideas by different people about the origin of submarine canyons. One of the names that you have not listed is actually that of Alex du Toit, who was, the great South African pioneer of
or
continental drift.
Alfred Wegener also.
Yes,
could be on
but
that
du
list,
Toit
right.
had written a specific paper on the origin of submarine canyons in the Pacific Science Congress, which is somewhere in the early 1940s, and specifically interpreting the origin of canyons in terms of continental drift and plate tectonics. That came later, of course.
Yeah, thank you. I could try to add that to my list. And Wegener I knew about, and there was apparently a tectonic origin, but I couldn't find the original material before this meeting, so I didn't add. I don't have people on that list unless I actually saw the publication.
I have myself one question. You don't seem to have discussed the study of the profile of the rivers on land. For instance, there's been known for a very long while that the Rhône in France had not the equilibrium profile expected from the current sea level. So which was interpreted early as indication that the sea level had changed over time. So was this kind of argument not involved at all in the discussion?
That's a good question, and there are profiles of the submarine canyons themselves, and I haven't gotten into the detail about the evidence for the sea level change on land, and of course there's a lot of this information as well, and the changes in profiles. There are profiles of submarine canyons, and they're very steep at their upstream end, and this is another question of like, how did this amphitheater form, in a subaqueous environment? But I can't really answer your question. I could add it to my list of things to do.
One remark, according to the dates you indicated, Shepard died at 114.
Did I have a typographical error?
There should be a typo there.
Okay, a typical error. He lived into the 1980s, 1985, I think, but yeah.
So